Hey all, this is the second lecture in Unit 2-3. We're going to talk about objects and their properties. Now, an object is essentially a data type, except this one allows you to have different properties that goes along with it. For example, if I just say x equals 5, I'm assigning an integer data type to the variable called x. But all it can really do is hold that integer. If I say, for example, x equals, and then in quotes, Purdue, I've defined x as a string data type, and along with the string data type goes a whole series of properties, like, for example, the indexes for each character, as well as, and we talked about all these methods for strings, like x.lower, x.upper, x.isDigit. There's so many properties and other features and methods that go along with an object data type. So a string is an object. A list is an object as well. And then the first lecture in this unit, we talked about graphics and graphic objects. Those are objects as well. Each has its own properties and settings, and you can modify them and manipulate them, but also retrieve those settings. So what is the center point of my circle? What is the radius of my circle? What are the properties of my rectangle? So objects are a data type that allows us to not only store data, but also to have properties that go along with it. So let's go ahead and get started, and let's talk about objects and their properties. So our objectives today are to talk about the basic concepts of objects, also talk about working with objects and their methods. And we've already done a lot of work with methods. Those are the object variable name dot something. So like a string dot lower. That lower is a method that goes along with the string. We're going to practice on some different object data types like strings, but also lists and graphic objects and those sorts of things. So let's first talk about some basic data types. An integer, x equals 5, that's an integer data type. A float, y equals 3.14159. It's a float because it has fractional value after the decimal place. If I assign a variable name equals Sansa, that's in quotes, either single or double, that's a string. If I say names equal, in square brackets, a series of strings, I'm creating a list. And if I say something like is winter coming equals true, I'm assigning the Boolean value true to the variable called is winter coming. So these are several different data types. Some of these are objects and some are not. A Boolean data type is not an object. It either holds true or false, that's it. There's nothing else that goes along with it. The same thing with an integer and a float. It just stores a value. But strings and lists are objects. And we know this because we can manipulate them, we can change them, they have properties, they have things like a length. We get the length of a string or the length of a list. And we know they're objects because there are different elements. So most modern and current computer programming languages are using what's called an object-oriented language. Basically, those objects contain data. And that data is more than just a number. X equals 5. I'm assigning the integer 5 to the x. All it contains is that integer, and that's it. A list might contain a lot of different data sets. So the object contains data, and an object has properties. Like, as I said, strings. That's a good example of an object. So some of these data types are actually objects with properties. As I said, a string, a list, graphics, objects. Those are all objects, but not Booleans, floats, and integers. Those methods that are built into those objects allow us to work with, manipulate, change, retrieve the properties of those objects. And even amongst objects, there's really two kinds of objects. Those that are mutable, changeable, and those that are immutable, not changeable. Mutable basically is just an adjective that means it's capable of change, mutation, right? So if I have a list and I assign list index 2 to equal something, I can change the list directly. If I use the list.sort method, it changes the list in alphabetical order. It actually modifies the data. Whereas string, that's not the case, right? If I have a string and I use string.lower, it doesn't change the string to lowercase. It gives me a separate copy of the string, all in lowercase. So name equals Sansa, lowercase. If I say print name.upper, this .upper method gives me a copy of the string in all uppercase, but the string itself, you see, is not changed at all. Print name.title, capital S-A-S-N-S-A, but if I print name index 0 to 2, you'll see that the S and the A are not capitalized. They're not titled. It's just a copy of the string that is titled. Because it cannot be changed, we must reassign that string a new value to modify its content. So if I assign it sansa as a string, I could say name equals, in other words, reassign. Remember, the equal operator is not equivalent to, like in Boolean, it's assign. So assign this string to the variable called name. I always think of a single equal sign like an arrow pointing left back at the variable. Assign this back to the variable. If I take the original string dot upper and assign it back to the variable, now it's all in uppercase. So I can replace the string completely with a new string, but I can't just say capitalize the first character in place because strings are immutable. So what's the output of this program? I've got two functions here, the myFun function and the main function, and I call the main function first. So my string equals a string to analyze. The A and the S are uppercase. My string dot lower, print my string. What gets printed here? You'd think, perhaps you would think, the whole thing in lowercase, but is that true? This my string dot lower doesn't change my string, it returns a copy of it. I didn't assign it to anything, so it may return a copy of it all in lowercase, but I didn't assign it anywhere, so it's just lost. They call that dropping it in the bit bucket, like you have a little bucket next to your desk, and all those extra bits of data just go over there. They're lost forever though. myFun and pass it my string. So I pass it my string, q equals q dot title, q dot upper. Now print my string again. What's the output? Is it going to be in uppercase, in title case? What's going to happen here? What do I get back? What is in my string at the end of this? And the key to understanding this is to understand that an immutable string or immutable object like a string is not changed unless you reassign it back a new value. So if I reassign it up here to new value, does it change it down here? It's interesting. Type in this program. You might pause this video. Type in this program and run it and see what gets printed for these print statements. See what happens. So the myFun function changes the string variable q into a titled string. And the line q.upper returns a copy of the uppercase, but since it doesn't reassign it, it's lost. Since myString.lower is not assigned, then it doesn't do anything. It returns a lowercase copy of it, but it doesn't happen. It doesn't do anything. So the first print statement prints the string in its original form. Now, although myFun myString is used in the next line, it serves no purpose because while the function applies the title method, it doesn't return the string. Remember, strings are immutable. Even if I reassign it in the other function, it's not going to be changed in the main function. So here I'm saying I input the string as q and I'm overriding that with the title case. I didn't return this. I didn't return it back to main. So I still haven't changed anything. I still haven't changed anything. So in the end, it prints the string in the original form, exactly how it appeared at the beginning of the program. Nothing changes because I'm not reassigning it. Now lists are mutable. When we define a list, it inherits all the properties of a list. So names equal Terry and Cersei, Jamie, names.sort. When I print names, lo and behold, they've changed order. They're now alphabetical because the .sort method for a list sorts it alphabetically. Names.reverse. And when I print it again, they're changed again. They're now in reverse alphabetical order. So list methods modify and manipulate the contents of the list directly in place because lists are mutable. So what is the output of this program? Remember, lists are mutable. So I have a function called myFun, which accepts something called q, and I have a function called main, and then I call the main function. MyList equals Andrea and John. MyList.append Albert. So what's in the list now? Now it should be Andrea, John, and Albert. When I print it, I'm going to get Andrea, John, Albert. My fun, my list. Notice I'm calling the function here. I'm not assigning its results to anything, but I am calling the function and passing it the list. The list gets passed up here and it's called Q. Q index 2 equals Pete. Not returning the list, but the function's now over. Control is sent back to main. Print my list. The question is, what will my list be? The first time it prints it, it has 3 values, Andrea, John, and Albert, because the append method modifies the list by adding that third value, that third name. When I call my fun and pass it the list, I manipulate that list. I change the index to what was Albert to Pete, but I don't return it. Is it changed? The answer is yes. I've modified the list. Even though it's in a different function with a different variable name, it's the same list because it's mutable and it's an object. And I can change it and it stays changed because it's a mutable object. So the second print is going to say Andrea, John, Pete. And again, stop this video, type this code in and try it. Try some other things and see what happens. The key is, how do you know whether you have to return the value or not? Is it an object that you're returning? That's number 1. And number 2, is it mutable? That's key. That's very key. All right, and this explanation here will actually describe what happens. I believe this is in your notes, in your handbook, that talks about the difference between the myFun function and the main function and what they all do. So graphic objects are also mutable. When we define a graphic object, like a point or a circle or a rectangle, it inherits all the associated properties of that object type. So they don't all have the same data types, right? A point pretty much only has an X and a Y coordinate, and that's it. A circle has a center point and a radius and a fill color and an outline color and a number of other properties, and rectangles also have a number of properties. Changing the properties of a graphic object in one function will affect that graphic object in other functions as well. So if I define a circle in the main function, and then I pass that circle to another function and manipulate it, it's changed. So you got to keep that in mind. Graphic objects are mutable. You do still have to pass them between one function to the other, but if you change them in that second function, they are definitely changed. Let's take a look at a program here. This is a graphics function, a graphics library program. From the graphics library, import everything. I've got a function called myFun. I've got one called main, and then I call the main function. So I define a circle called myCirc. MyCirc is a circle at point 10, 10, radius 10. That's what how this all works out. Print myCirc.getCenter.getX. In other words, just print the X coordinate of the circle. What is the X coordinate of the circle? Well, I just defined it. It's 10. Then pass that circle to the myFun function. Comes up here. In myFun, it's called Q. It's circle though, but it's called Q. Q.move 10 in the X and 10 in the Y. Remember, the move method doesn't move it to a point, 10, 10. It moves it an increment. So the circle started at 10, 10, and this move method will move it 10 pixels in the X and 10 in the Y. So where would it be now? 20, 20, right? Well, this function is done, comes back to main, and it says X equals myCirc.getCenter.getX, print X. These 2 lines are equivalent to this 1 line right here. What's it going to print? Where it was originally, 10, 10, or where it was moved to? The answer is circles are graphic objects. They're mutable. So it's going to print 20 because the circle has been moved. And that makes sense when you think about it, right? I've got a circle. I pass it out to this other function. The other function changes it, maybe changes its fill color or does something to it. When control passes back to my primary function, my main function, the circle is still changed, right? So in this case, it will print 20 because that's where the circle is right now. And that's what this description does. It tells you that it moves the circle by 10 pixels horizontally and vertically, and it changes the object directly. So when control comes back to the main function, it is in a new place, and it prints 20, as that is the new x coordinate for the circle. All right, now there's a lot more to work with here with objects, but I want you to make sure that you practice this, right? So the programming exercise in the lab 2-3, they give you lots of practice working with objects, getting values, setting values, etc. And these are the preliminary to your milestone 2, where you're going to be creating lots of objects, a graphic object, but also you're going to use a GIF, a graphic file, to create a banner at the top of a game program. You're going to create a bunch of circles. You're going to create some lines, some text objects with numbers in them, a whole bunch of things, rectangles and so on. Lots of different colors and shapes. You're going to have to use your algorithm knowledge, your experience with for loops in creating a pattern of zeros. Make sure you go take a look at the milestone 2 document so that you understand what it is you're going to be doing. There's an example of it as well right there in Unit 2-4 that shows you what that milestone 2 program would look like. However, Unit 2-3, this unit, is the one that's going to get you ready. So you might want to look at other graphic program examples that we've given you for some examples of the format, but the primary thing, the base level thing for you to do is read Zell Chapter 4. The whole chapter is about the graphics library. All the things you can do with circles and rectangles and text objects and entry objects. It is a fantastic chapter with lots of cool stuff in there and things that you're going to want to do. All right, great. Don't forget, take the quiz that goes along with this lecture. Have a great day, have a great week, and code on, Python Knights.